This video is about required practical 6, where you have to find the EMF and internal resistance of a cell using this setup here. Okay, in my class, you'll be tested on CPAC 2D, where you have to select the correct equipment and set it up without any help. It'll also be tested on 4A and 4B, which is that you can measure the terminal voltage and the current, have a suitable table, and you record the data in the table without making any mistakes. For example, you're writing them all to the correct number of decimal places. Okay, step one is to plan how you're going to set up the equipment. Because you'll be tested on being able to set up yourself, you'll just be given a bunch of equipment like this. Okay, so a cell or battery that might also be in a holder like so. Okay, a voltmeter, ammeter, rheostat, connecting leads. You might be given other equipment as well, just to check that you can identify the correct equipment and use that. Okay, I would suggest starting with the cell, the battery, and then connecting the variable resistor across it like so. Okay, so we're using the rheostat, and you have to connect these two ends of the rheostat. Okay, to figure out how the current is going to flow through your rheostat, just trace its path through the rheostat. Okay, so for example, in this case, it'll start at the top left corner and it'll go around like this. And it doesn't matter where it starts. It could start at the bottom right as well, but that's the path it will follow. And I'm going to start with a large resistance, which means that's flowing through all of those coils. So very large resistance, because if I start with a large resistance, that means the current will be low. And it's better to start with low currents because high currents can have heating effect and could burn things and so on. Okay, then I'm going to slide it along, and then once again you can see the resistance is going to decrease because I'm reducing the amount of wire that the current has to flow through. Okay, and then that being 0. Okay, so that's how I'm going to set up the circuit. Then next I'm going to add the measurement devices, the ammeter. So I'm going to add it in series like so. Okay, open up the circuit and connect it in series, and then connect a voltmeter in parallel. So just clip it across the variable resistor like so. You can also clip it across the cell if you wanted. It doesn't matter, it's still measuring the terminal voltage. Step 2 is to make a table so that you can record your results. So here you can see I'm measuring terminal voltage and current. I've put the units, so ensure the units are there, otherwise you will lose the mark. And you're being tested on this, so your table has to be perfect. Okay, I'm going to use some example data here to show you what not to do. So if you look at the first column here, all the data in a given column should be the same number of decimal places. As you can see, I've made a mistake. That 1.4, so what the person really means is 1.40. Okay, so it should be the same number of decimal places. Now you might argue it means 1.4 and 1.40 are the same, but they're not. Okay, 1.40 is more precise. So you need to make sure it's all the same number of decimal places. And finally, also, I just want to point out how you should try to get a nice range of data spread out across all the currents. So if you look at my data, there's too many points over at the low currents, but there's not enough in this tiny region at the bottom. So this might be because when I was using the rheostat, I moved the space of the rheostat in equal steps, but you need to look at your data as you record it and make sure that you're getting a nice spread of data. Step 3, carry out the practical. So I'm trying to find the internal resistance and the EMF. I'm going to start with high resistance in the circuit, so the current is slow, and I'm going to reduce the resistance. Okay, as I reduce the resistance like so, the current in the circuit is going to go up because the total resistance is decreasing, so there's going to be more current. Now, if there's more current in the circuit, that means there's going to be more lost PD. Because of the internal resistance, we're going to lose some voltage there. So the voltage across the variable resistor and therefore the terminal voltage is also going to decrease. I'm going to write those both down in the table, so the current and the corresponding voltage, the terminal voltage. In my class, you don't need to do the following steps to pass the CPACs, however, I do recommend it. Plot a graph of terminal voltage against current. Now you can see from this graph how I've collected quite a lot of data points at low currents, but not enough at large currents. So make sure you don't do that mistake that I made. Okay, so the equation of that I'm using is terminal voltage, internal resistance, current, and EMF like this, and I've rearranged in a way that I can compare it to an equation of a line, y equals mx plus c. So on the y-axis we've got V, on the x-axis we've got current I, and so the gradient is minus of the internal resistance. The intercept is the EMF. So if from my graph, if I get the gradient and the intercept, it looks like this, my equation of the line. So my internal resistance is 0.22 ohms. Okay, that's quite small, that makes sense. It shouldn't be too large. And my EMF is 1.45. So I would compare this to what was written on the cell that I used. Okay, if it makes sense, if it's something close. I'm not too off. I think mine should have been 1.5, but I got 1.45, which is close enough.